Okay, so work solution 14. So we're doing a cylindrical pressure vessel, and we've got this is 2.5 meters long. It's telling us the internal diameter, 60 centimeters. We look at the cross section. We're told the thickness of 8 millimeters, and the internal pressure is 1 megapascal. We've got some Young's modulus values, Poisson ratio, and we're being asked to find the hoop and longitudinal strain, the increase in diameter and the length of the vessel, and the change in volume. So the first thing we want to do is to write out all our data and to convert it so that it's in SI units. So for example, the millimeters will convert to 8 times 10 to the minus 3 meters. The length, well, that's fine, we can keep that in 2.5. The internal diameter, be careful here, so pay attention. Is it internal or external? If it's external, then we will more probably want to take off the internal. So that's in centimeters, so that we'll convert that to 0.6 meters. Megapascals, so look out for the prefixes, and let's get rid of them. So that would be 1 times 10 to the 6. We've got a giga, so that's 1 times 10 to the 9. And then got the Poisson's ratio, no need to convert that, it's a ratio of numbers. Ratio of strains. So here we've got the values we're going to now use in our equations. And so this is our original data. We can throw that away. Okay, so we've got all our data ready to go. Think about the first question, which is to work out the strains. So use our formula sheet and find the strain equation. I think we've got two options here, haven't we? So what you want to do is look at the data that we got and look which ones where we can fill in the data. So we've got a P, a D, we've got the thickness, we've got the Young's modulus, and we've got the Poisson's ratio. So this is the equation to use. This is going to be the hoop strain. Substitute all my values in, and I get a strain result of 1.6 times 10 to the minus 4. General rule of thumb is that you're looking for results between 1 times 10 to the minus 3 to about 1 times 10 to the minus 5. They are the typical sort of structural strain values you would expect to get. So this falls nicely into that range. Let's do it now for the longitudinal strain. Substitute our numbers in, and we are expecting less longitudinal strain than hoop strain, so we've 3.75 times 10 to the minus 5. Strain is a ratio, so we don't have any units. Next we're going to look for the change in the diameter. So hoop strain, that's how much things are getting pushed outwards and then potentially cracking in this direction. So that's going to be based on the diameter, and longitudinal, well, that's if this thing splitting into two. So we're looking at how much it's increasing that in that direction for longitudinal strain. Going back to the hoop strain, that's based upon the internal diameter. So the change in diameter is going to be this rearranged. So the internal diameter times by the hoop strain, that gives me the change in diameter for the internal diameter. Now let's look at the increase in the length. So rearrange that, times it by 2.5, and now we've got how much that's increased. So we've got how the diameter has increased and how the length has increased. To work out the volume, we've got two options. One way of doing this is to make sure that we have, first of all, these results need to be as accurate as you can. So you don't want to be rounding these answers really. So now we're going to go back and work out what the volume is based upon cross-sectional area. So that's going to be pi d squared divided by 4 times by the length, which is going to be 2.5. So that's the volume that's in its unpressurized state. So again, write out these numbers, all the figures you've got available in your calculator. Do not round. The next stage is to go back and to take what we've worked out to be the extension in terms of the diameter and add it on to the actual diameter, and the extension in terms of length, add it onto the length, and repeat the formula. Pi d squared over 4 times L. Okay, so we're going from that to pi d plus delta d squared times L plus delta L over 4. So this row we don't want to round because the first three figures are pretty similar. We can now work out the change in volume by taking the new volume, take away the old volume, and this result is going to be in meters cubed. Don't forget that. And that's it. Job done.